Welcome back, everyone. Looking at 13.2, dependent relationships. All right, so we're going to have dependent samples in this section, which we had talked about briefly in the last video. Matched pairs is what we're talking about. So we have a simple random sample of size n on both. N1 and N2 are the same. So we're talking about before and after relationships, twin relationships, or perhaps married couples, for example. All right, so the reaction times in an obstacle course are measured for 8 randomly selected drivers before and then after the consumption of 2 beers. So we've got matched pairs here because it's the same people, 1 through 8, but before and after drinking the alcohol. In a matched pairs experiment, the size of the 2 samples are naturally the same size, and each X is naturally paired with a response Y. Okay? This being the case, we can set it up so that we are testing the outcome of one mean value, the mean of the differences, and then we can use a simple t-test as we've done before. So we combine the 2 samples together to get a sample of size 20. And then we'll get 20 differences, in other words, 20 data values in the list. So there's 2 ways you can do this. You can copy them down in both lists and then calculate the differences, or you can just calculate the differences and then have that be its own list. And then we can use a simple t-test, as I mentioned before. All right. Because we have reduced our data from 2 pairs of matched data to 1 list of differences, our hypothesis will differ from the previous section. So here the difference between the means is, we'll just call it mu sub d. The null hypothesis is that mu sub d is 0. In other words, the differences are, there is no difference, so there's no change. Alternative would be that there's a change in the negative direction, or change in the positive direction, mu sub d is positive, greater than 0. Or not equal to 0, so there was one or the other change above or below. So here's an example for twins, identical twins. So the hippocampus being a gland in the brain, and we're looking at the volume of that in 15 pairs of identical twins. One twin was affected by schizophrenia, and the other was not. And the test was with significance level of 0.05. So the null hypothesis says that the average difference, the average of the differences is 0. Okay, and the alternative says that it's not 0, which means that they have different size hippocampuses or hippocampi. So these numbers represent from the set of twins that are not affected. So this is the 15 twins that are not affected by the disease, and this is the 15 that are affected by the disease. So we could punch these into the calculator, and we can start by going to the edit menu, and we can erase any previously created lists. I'm going to need at least 3 lists here, so I'm going to clear these out. So on list 1, I'm going to type in the 1.72 up to that 1.86 there. I'm going to make this small just briefly so that, oops. Okay, so there we go. 1.72, 2.16, and all the way down. 1.48, 1.18, 1.64, 1.7, oops, 74. Anyway, I'm just typing in the data. Okay. 1.09, 1.46, 1.74, 2.53, and so on. All right, then I go to the other list and type those in. So you go ahead and do that while I'm doing this. Okay, so what I'm going to do now when I have the data on my calculator, just checking that everything looks good. Just making sure I typed it in right. Yeah, looks pretty good. Yep, that's right. Okay. So then I'll go over to list 3, and I can say, go up, hit enter, and I'll say L1 minus L2, and that will give me the differences here. That'll give me the differences of each individual, this is the twin without schizophrenia, this is the twin with. So I can see the difference is going to be a positive one. In other words, the twin without schizophrenia has a larger hippocampus. So all the ones that have positive numbers means that the hippocampus was larger. All the ones that have negative numbers here means that the hippocampus was smaller in the non-affected twin. All right, so the next thing I can do is I can go stat, tests, t-test, remembering that this was the number here that the differences are compared to, which is 0. So that has to be 0 when you're using a simple t-test here. So if we're using data, I have to switch over to data, and it'll calculate all of the stuff for me if I have the correct lists. Well, this list is list 1, so I have to make it list 3. And then I'll go to not equal to, and then calculate. Okay, so there's my test statistic, and there's my p-value, 0.0098. So it looks like we are going to fail to reject here. No, that's incorrect. We're going to reject the null hypothesis because this number is less than 5%. Okay, so what that means then is that we are going to accept the alternative, meaning that they do have different sized hippocampuses, they being the twins. Okay, so if we finish up the slide here, there's the differences, and we can see that there does appear to be an overall trend toward a larger hippocampus, but again, we can check that using the statistics, which is what we just did. So going all the way down to the end, we do reject the null hypothesis that there is sufficient evidence to suggest that there's a significant change of the hippocampus at the 0.05 level of significance. That concludes this video.